So let me begin by saying welcome and thank you for coming. We've got a few other people that are joining their evidence in the participants panel. I'll let everyone know that in this environment, you are welcome to discuss anything that's going on in the chat. I will let you know that anything that you type in there is recorded. It won't necessarily be shared with the group unless there are some hyperlinks or anything like that that you'd like to see. But I want to thank you for coming. A couple of news items for you before we get started. One, I posted an announcement about 15 minutes ago, just to give you an idea about what you're up to as the course winds down, the last couple of things you have to do. And I do encourage you to go and look at the course wiki for sample collaborative inquiry projects, particularly related to the reflection piece. There are a couple of reflections in there, and that's kind of the last piece that's got to be handed in at the end of the month. And on Monday, of course, your final independent projects are going to be handed in. And I let you know in that video that there are, in that video announcement, that there are some feedback that's coming your way in the next little bit. Tonight, it's kind of seniors night. It's like the specialist evening. And in the last number of summers, and when we run the course in the winter and fall, what we do is choose an end of the semester, end of the course period of time where the specialists share their project work. So in part one, you do some research and you build lessons. In part two, you build more complicated lessons. And in the part two course, you're challenged to sort of create video and to put yourself out there a little bit with audio or video. And in the specialist course, it's all about leadership. So you will have seen Mike in some of your discussions in the part one and part two discussions for each module. And this is this opportunity to sort of build those leadership muscles a little bit with a live presentation, a synchronous presentation, which is kind of rare in the e-learning world. There's not too many courses that do this type of thing, but you've signed up for integration of information and communications technologies, and we're going to do some of that tonight. So I'm going to remind you all that this meeting is being recorded. It'll be shared in case anybody wants to see it who isn't able to attend. But we'll be here for 20 minutes or maybe give or take a few minutes, including that questions and comments that you might want to share at the end. But if we're all set, I'm going to turn over to Mike.
Thanks, Rod. Thanks everybody for coming. Just to give you a quick introduction about myself. I'm currently the numeracy facilitator for Huron Superior Catholic District School Board here in Sault Ste. Marie. And with the new math curriculum rollout, I thought what a great time for me to dive into coding, as I think that's going to be one of the areas teachers are really going to be looking for support. And so about a year ago, I did a little bit of training with Science North, and if you haven't seen the Science North Blue Coat program, which is from Sudbury, Ontario, it's fantastic. They will join your classes virtually and do some coding with your classes, so I highly recommend that. But a year ago, I did that with the microbit, and I said, well, I'm going to dive back into this, and so this is going to be about coding with microbits. So I'll start sharing my screen here. And hopefully all of you are going to be able to see it. Is everybody okay? Can see that? Great. I see a few thumbs up. So I want to just first start with the hardware itself. And the microbit is just a little small pocket-sized computer. You can see from the diagram here that it has a USB, it's a micro USB connector that connects from the microbit to your computer. There are 25 LED lights, 2 input buttons, an A and a B, and it has pins at the bottom. And those pins actually, we can connect alligator clips to the pins. You can connect it to speakers, you can connect it to digital devices, a whole bunch of different things. On the back, we have a reset button, which will go to factory defaults, a battery socket, a microprocessor, which there's a lot in that processor. There's actually a temperature setting, so the microbit can deal with temperature. It also has a compass, an accelerometer, and it has light sensors as well. So there's so many things that this microbit can do. I wish I had more time to talk all about it, but if you do some research, it's a really nice piece of hardware that you can integrate into lessons in a lot of different ways. Just to name a few, I looked at today, and math lessons I'm going to show you today with probability. There's also a really nice grade 4 rocks and minerals, where you can actually be a geologist and identify minerals. And one that I really like as well that I've done with a grade 3 group is habitats and communities. And you can turn your microbit into a plant. And the students have to give it sunlight by pressing the A button every so often. They have to give it water by pressing the B button. So it's just like their own little plant, as well as it could be your own little animal tracking animal device. So I've used it in a few ways in the classroom, but I'm really, really looking to dive into the math portion. And today I'm going to show you how we can code rock, paper, scissors at the end of this. So just to give you another look, this is really how it connects, just that micro USB cable to your computer and right to the microbit. So for today, I thought we would use MakeCode. It's a Microsoft product. And so I'm going to go to makecode.microbit.org. And if any of you are familiar with Scratch, it's very similar. It's a block coding project. And when I look at the home screen here for this, I have all my projects laid out here on the top. Down below, there's tutorials, live coding events, games. There's a tons of resources here that you can start off with to help you sort of build your comfort level with this microbit. But I'm going to click on New Project here, and it's going to ask me to give a name to it. I'm just going to call it an introduction because I'm just going to introduce a few things on how we're going to code this. And unfortunately, I asked Rod, but he said it wasn't in the budget to send all of you microbits, so you guys can't have your own sitting next to you. But no, what we'll use is just a simulator here. So this MakeCode has the editor workspace over here to the right. On the left is the simulated microbit. So whatever we code, we'll be able to test it here on the simulated microbit. There's the home screen to get us back to the page we were at before, and you can share your coded project on all of the social media or get the embed code as well by clicking the share button. Down at the bottom, you'll see is the title. I can save, and this is my download button. I have my microbit, the actual microbit here, and so I can download any program that I want to it tonight. One thing that I used when I first started learning about the microbit was these are called event handlers, and that's how we're going to program this thing. And a lot of them are difficult to know what they actually do at the start. If you right click on the event handler and you go to the help screen, it brings up a reference guide to tell you what each of those event handlers are going to do. Obviously for the start, every time I load my microbit, whatever I have into the on start is exactly what it's going to show. And for the other example is the forever, that's always here. If whatever I program it to do forever, it will just keep looping and so on and so forth. Okay, so just to get started, I was going to show you how to use some of the basic inputs here. We have some built-in icons. I just click and drag, and I'm going to put it into the on start. And if you click on the down arrow, there's a whole bunch of set icons that are already here. My son loves the giraffe, so I always pick the giraffe. And you can see that on the start here, my simulation shows that giraffe. And every time I start up my microbit, that will show here. In one conference I went to with Science North, they made us pin our microbit on our shirt, and we used it as a name tag. And so if you click the basic and you go to show string, a string is just a fancy name for text. And I put it into the forever, and I click on that, and I just put my name, Mike, here. It is going to just go ahead and loop after, and it's going to show Mike the whole time. So that was kind of a fun way to meet each other as our names scroll across. So that's just the basic. Let's show you how to actually use some of the really interesting things. The inputs are the A and B buttons. Those are the most prominently used. If I pull the event handler from the input section, on button A press, again, I can go and look at any image or a string. The other cool thing that you can do is show LEDs, and you can actually program whatever picture you want. Maybe you want to do a happy face with some big eyes, and there it is. Once my simulator turns color, I'll know that it's ready. And if I click the A button now, it's going to show my happy face there, which is kind of cool. Let's just say you wanted to create even a simulation of some kind. I really like to do animations. And so what I can do is add another show LED below. And now I'm going to show this thing winking. And if I press the A button, once this thing turns color again, you can see it'll show it, and then it'll show the blinking icon, which is kind of nice for animations. You'll notice that it didn't last very long. So I don't like the fact that that animation's not going. If I click on the loops event handler, there's a repeat, and then take my LEDs and I can throw them right in there. And now that animation is set for when I press A, it's going to show the blinking eye 4 times or as many times as you choose. So there's a lot that you can do with just the basic event handlers, the inputs, as well as using loops as well. So that's kind of a nice way to do animations. I let the kids have some freedom when they did this last year, and you can imagine I had lots of fun things flashing around the room. The other thing that is really, really cool that the thing I like the most is this microbit actually has an antenna that can communicate to other microbits. So students have the ability to communicate with each other through these microbits. They can send images, you can send music. And so what we do is we send data their way. And I'll show you that a little bit better when I do the rock, paper, scissors simulation here to show you how this all works. So if I go back to the home screen, it's going to take me right back to that main page, and you can see it automatically saved that introduction for us. And it's there for you. You could see I was playing around a little earlier with some other tasks. What I want to show you is a project that uses the accelerometer, and I'll put RPS for rock, paper, scissors. I don't know how many people have seen this. It's a pretty popular task, but this would really fit 2 curriculum expectations. If you're a math teacher in grade 6 and you are trying to deal with theoretical experimental probability, we can actually create the task, turn this into a rock, paper, scissors. You can create the data, create graphs, and then actually determine the theoretical and experimental probability of these things and communicate with others. So it's pretty cool. I'm not going to need the on start and forever. So if I right click these, I can just delete these blocks. I don't want them in my workspace for now. What I'm going to start off with is, in this case, I'm going to use the input and on shake. The accelerometer can feel when the microbit is being shook. And we're going to have to use variables. So in coding, generally variables are used to store information. And because we are going to have 3 options for our rock, paper, scissors, I need to store my variable to understand that it has 3 options. So I'm going to go to variable and create a variable. And I'm just going to call it hand because we would be hand gesturing our rock, paper, scissors. And I'm going to take this set hand to 0 and I'm going to put it into my on shake. And what I need to do is program my microbit to understand that there are 3 choices. So when I go to the math event handler, I'm going to look for a pick a random number. And I'm going to throw it into where the 0 is. And essentially what I'm doing is I'm setting my variable to say that there are going to be 3 number options to choose. And those numbers are going to correlate to an image that I'm going to set up. So I don't want to go from 0 to 10. I want to go 0 to 2. And often people will say, why are we using 0? And coding 0 is very normal to use as a numerical value. So I've set my variable to pick a random number between 0 and 2. What I need to do now is set up some logic. I'm going to use some conditions. And again, this conditional logic is actually a part of the grade 5, 6, and 7 mathematics curriculum now. We have to teach students how to code and rearrange coding based on this. And I now have to use some comparisons. If I go to logic and I go down to the bottom and I'm going to compare my variable, I'm going to slide this into the true statement. And I'm going to go back to my variable now, my hand variable. I'm going to first put it into my first slot, and I'm going to compare my variables. So when my variable hand is equal to 0, I want it to show a picture on my microbit. So I'm going to use the show LED, and I am going to draw a picture of scissors. There's my scissor icon. So right now the microbit knows that if when I shake it, the number 0 appears, it is going to show my scissors. Of course, there's 2 other options that we have to consider. So I'm going to hit the plus button here twice. I have to do one more comparison. Nice thing about this block is I can go and click this comparison, right click it and just duplicate it. Makes another beautiful piece for me. I'm going to drag it in to the else if. So we already have our hand set to 0. So I'm going to set my second one to the number 1. So that if my microbit gets 1, it's now going to come up with, and for this one, I'll show paper. I don't know, my best paper is just, there's lines on paper. So let's go like that. So if my microbit gets a 0, it's scissors. If it gets a 1, it's paper. The else, I don't have to put any comparisons because this is the only other option. This would be my rock. And there it is there. And so what I've done is I've given those three options through logic and through setting up a variable. You'll notice that on my microbit here, there's a shake button. If you had the physical microbit, you can just shake it. I'll show you that in a second, just so you don't call me a liar after. And I can press my shake and it's giving me all the different options here, which is cool. I can also use these values here to make my screen big so you can show it to your class. And I just think students will use their data and take so much more pride when they create their own data as opposed to just getting the data in a textbook. So I think this is a really nice way to incorporate both the coding and the probability piece for them. So we used a lot there, and it really is a lot that I threw at you here in this, but what I found was you can really be shown this as much as you want, but to really, really start learning, you have to dive in and you have to play with these things and really go through the tutorials. I think it really makes for a lot of fun if you enjoy coding. The other thing that I'm trying to learn is they allow you to go to JavaScript as well. If you click at the top and just click on the JavaScript, it's going to transfer everything I've done to JavaScript, which I think is really, really nice. You can show the students that we're using this block, which is, really a primary starting point for coding. But this is what real coders do when they're trying to code programs and work with coding. So I like that we can go back and forth. It's a really nice touch. Any questions so far? Everybody okay? Great. I do want to now actually put you on the spot and try a few things here. There's a beta version of Microbit Classroom that has been developed. And so what I'm going to do is I'm going to go to classroom.microbit.org. I already have the tab up here. And I'll show you how easy it is to use the microbit with your class. If I scroll down a little bit, I'm going to give my activity a name. And in the short amount of time that we have, I'll see if you all can code a graphical die. You have the choice of using the programming language MakeCode or Python. Today, obviously, I just talked to you about MakeCode, so we'll choose that one. And when I launch my classroom, it brings up a classroom version very similar to if you're familiar with Desmos or some of the other platforms out there. It's so nice. I can go to my dashboard here, and all of you now, if you wanted to go ahead and go to the URL, microbit.org/join, it'll ask you to put in a classroom name. It's really secure. You're going to put Indigo, Bear, Sailboat, and Guitar, and then throw in the pin at the bottom. And you will join as students. And as a teacher, I'm going to be able to see all of you joining by looking at my dashboard. I'll change it in a minute here once I get everybody a chance to see this. So I see people have joined already. You can still see the classroom name at the top here with the pin and the URL. Rods are already here. Others will join. And what's really nice is I can watch all the students' code. So I can see exactly what Rod is doing on this screen. It's going to load exactly what he's doing on his editor screen. I can click on Josh. I can do click on individual student and see exactly what they're coding. The other thing I really like is on my editor version, whatever, you might look at a student and say, oh boy, Rod, yeah, he's really lost. He's not dealing with the right event handlers. He's lost in there. What you have the ability to do is you can start off some code for them and say, okay, well, we should be starting with on shake. And then I can share that code with students, and I can pick which students I want to share it with. So if I just want to send it to Rod, I can say, okay, I'm just going to send this to Rod because he seems to not know that we need the event handler to shake to start. And then I can send it to him, and on his screen, he's going to be able to see that teacher sent you a code, you accept it, and now that student's on the right track. So what a nice way. God forbid we're in remote learning again in September, but if we are, I think what a nice way to be able to watch the students live and see what they're coding. And there's just the example of what Rod has up on his screen. The other thing that's nice is you can download a report for all students. You might not be able to watch every single student all the time. At the end of a session, you can download it. It downloads as a Word document, and it prints a print screen of exactly what they have in their editor workspace, so you can see if they got it correct or not. So a lot of good things happening with the microbit classroom. And there's really nice instructions to get you to set this thing up. You have your editor space exactly like on the MakeCode site, your dashboard to help you look at the students, and your student code. Top right-hand corner, you can go ahead and save your classroom, save where you were at, or you can download the HTML file. So I really think this is something I'm going to utilize, especially when I'm working with teachers and trying to share with them coding with the microbit. I can do it right here online. So I don't want to take up too much of your time, but if you have any interest in coding, I think the microbit is a great way to start. I'm going to stop sharing my screen for a second. I want to make sure all of you know that here's my microbit, and when I shake it, it is working. It comes up with all the data here, which is a lot of fun. We started a microbit coding club at one of the schools I was working with, had a ton of success. I think for the microbit, you're probably looking grade 4 as maybe the starting point. I don't think the primary grades could handle it just yet, but I think grade 4 is a good place to start. Anybody have any questions or concerns?
I can't believe we covered so much in such a short amount of time. I'm in awe. It was really, really wild. Does anybody have any questions? Like, I'd like to know, maybe folks would like to know. So I want to try this out. Where do I get my microbits at?
Yeah,
Rod didn't get them for us. So.
Yeah, it couldn't make the budget. You know what? I bought my microbit. I got my microbit through Science North when they came and did a little bit. They supplied it, but on Amazon they're really cheap. $20, 19.99 on Amazon. And there's another. There's a whole bunch of add-ons that you can get with the microbit. There's a sound sensor that you can attach to the pins. There's a further temperature. The one is pretty basic on this microbit. That's about $50. I bought one of those as well. True story. I connected my microbit to a speaker in my classroom, and when the noise level got to a certain point, it detected how loud my classroom is. It just a loud like buzz went at them. Um, so we did that to code that. So had a lot of fun with that. Anybody
I
else?
see a hand up. You feel free to unmute yourself and ask your question, Natalie.
Yeah.
Hi, Mike. Well, you already answered my question about how expensive it was, but I'm just wondering how many of those would you recommend in a class? Like, do you need like a full class set, or like how many?
Yeah.
To buy them.
I've been really fortunate that we have a whole bunch that because when you buy in bulk, they're actually a lot cheaper as well. So we were able to spend very limited amount of money to get a class set. But I worked one other time with students where they were sharing. I got to be honest, it's not the same feel that they want their own. They want to be able to code on their own. So I like having every student to have one in a perfect world. But it did work okay when they were in pairs.
Okay, thanks.
No problem.
Does that Microbits website have lessons and ideas on it as well?
Absolutely. So I didn't mention the microbit.org. I was too excited with my coding. If you go to microbit.org, there is a getting started guide. There's projects, there's lessons where you can find, you'll find the rock, paper, scissors one on there, microbit.org, as well as that Make Code website has a lot of resources and lessons there for you.
Quick question. Have you used it with Arduino or any other boards?
I have not. Quick, simple answer for you. No.
In what other situations, because I like your example of the noise level in your classrooms, what other situations do you foresee using this in a classroom?
Yeah, so the one of the things that are coming out is, I can't remember the name of it. It's a microbit car where the microbit actually fits into a little Lego style car, and it is able to track speed, acceleration, and you can have little races with the kids as science applications. Like I mentioned with the plant, you can also do circuits on here as well. To teach that kind of science concept. But I'm really more focused on the coding aspect and the implementation in the mathematics curriculum. But there is so much. I mean, I gave you a crash course in this and what this thing is able to do. There is so much more. I don't know if I said that there was a compass, the radio antenna. There is a ton of stuff you can do with the radio antenna. The students really loved connecting to each other through their microbits. That was a really popular hit last year. So
I find myself wondering, is there a way like you could get kids to program like COVID simulation or something like that, where microbits that come in contact with one another react in a certain way?
Yeah. Well, you could, it has a sensor in there with the compass. If you treated the virus as a magnet, and the closer you got to the magnet, the LED lights can light up.
Interesting.
That's one thing. And I created a night light for my son the other night. He said, I need a night light. As the light goes down, those light sensors pick up that it's darkening, and the LEDs will light up to work as something like a night light as well. So you really have to dive into this thing to learn its capabilities.
This is the kind of thing, like I could see kids making alarms for their bedroom if someone sneaks in. That, you know, it's a matter of like when Steve Jobs and they built those iPhones and they put accelerometers in them and light sensors, all these things in there. He thought, well, what are people going to do with it? And here's a real practical example where they understand and see these components are in the objects that we use every day, but there's actual programming to make them behave in any of a variety of ways. I'm just going to pause here for a second, knowing we're not going anywhere, but I want to take a minute now to thank folks for coming, because we're at 30 minutes and we said, hey, it'll be 20 to 30 minutes. And so if you have to head out, you're welcome to wave and say goodbye and maybe catch the rest in the recording, but we'll stick around for a few minutes for people that have other questions, and you're welcome to stick around.
And I will say one more thing. There is, was able to download, there's a microbit app for the iPhone for sure, and you can program right from your iPhone. So that might be something that could be interesting for students right from their phones to code the microbit. Any other questions?
Well, I'm super happy that so many people made time in their evening to join us. On behalf of the whole group, Mike, let me say thank you for preparing something so well that it was condensed, but able to cover so much stuff. And really, it's not a full blown up workshop on this thing, but you certainly whet our appetites. And if that's what your intent was, to get us curious about this, especially in light of what we know is coming in the curriculum, I think you did a terrific job. So on behalf of the whole group, thanks very much.
Thank you. I had fun.